Henna, or mehndi, has been a centerpiece of celebrations across various cultures, including Indian weddings to Egyptian mummification rituals. Today, it's one of the most popular traditions during festivals like Diwali and Eid. But what if I told you that this ancient art is powered by cutting edge chemistry? Henna is a temporary dye usually found as a paste in a cone. But how is it actually made? Henna comes from a plant called Lawsonia inermis. The leaves of this plant are dried and then crushed into a powder. The powder is then mixed with four different ingredients: lemon juice, water, essential oils, and sugar. All four of these ingredients combine to form the henna paste that we know. The molecule responsible for henna stains is called lawsone. Lawsone has a natural affinity for binding with proteins, which just so happen to be in your skin. So when the paste is applied, lawsone interacts with these proteins to create a henna stain. Your skin is made up of many different layers. In this picture, you can see the dermis and the epidermis. The epidermis has many different cell layers, but the first layer, called the basale layer, is the only layer with living cells, meaning the rest of the cell layers are dead or keratinized. These cells include a protein called keratin, which is why they're called keratinized cells. Keratin is the main protein in your hair, nails, and the surface of your skin. So this is the protein that lawsone interacts with to create a henna stain. Three main steps to the interaction between lawsone and keratin. First, lawsone is activated when mixed with an acidic liquid, hence the lemon juice in the henna paste. This acidic environment stabilizes the lawsone molecule and makes it more reactive. Second step, a covalent bond forms between the lawsone molecule and the keratin molecule because of the different functional groups present in both of them. Third, the orangey brown stain that henna is known for. When this interaction occurs, the skin cells actually turn orange. The darkening of the stain to a darkish brown occurs through a process called oxidation, similar to how an apple turns brown when you leave it out. Henna is semi-permanent, meaning it only lasts about 1 to 2 weeks. This property of henna is due to the fact that it only stains the top dead layers of the skin, as these cells naturally shed to take the stain with them. Interestingly, henna lasts longer on certain areas of the skin like the palms and the soles because of the thicker, more keratinized skin. More keratin strengthens the bond between the skin and the dye, slowing the fading process. Another property of henna is its cooling effect. As water from the reaction and the paste evaporates, it absorbs heat from the skin, a process called evaporative cooling. This helps explain why henna has been used for centuries in hot climates, not just as decoration, but as a relief from the heat. From hair dye to natural sunscreen, henna has inspired countless innovations. So whether you're diving into the science of natural dye or exploring the art of design, stay curious because who knows what fascinating discoveries lie at your fingertips. Literally.